All right, now we are on 2011 question number 3 from the AB calculus exam. All right, here we have let R be a region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine of pi x, as shown in the figure above, or to the side in this case. Which of part A, write an equation in line tangent to the graph of f at x equals 1/2. Now before we get started, one thing I like to do is make sure you identify which graph is which. All right, our x cubed graph is going to be this one. This is going to be f of x here. And our g of x is going to be the one coming down. And they were kind enough to give us the point of intersection, that 1/2, comma 1. Okay, so now we know which graph is which. Let's start off with A. A says write an equation for the line tangent to the graph of f at x equals 1/2. Well, what do we need for a tangent line? We need a point, which they actually give us. So we got 1/2, comma 1, and we need a slope. In order to find the slope, we're going to take the derivative. All right, so we need to take the derivative of f of x. So f of x was 8x cubed. F prime of x would then be 24x squared, and we're going to go ahead and put in 1/2 for that to find our slope. So 24 times 1/2 squared, well, that's going to be 24 times 1/4, which is going to give us 6. Now again, free response, we don't have to simplify anything. If you want to simplify it, you can. Sometimes it makes it a little bit easier for writing stuff out later, or you can leave it totally unsimplified. But now that we have our point and our slope, we can just plug it into our point slope. So y minus y1, which is 1, equals 6 times x minus 1/2. And that is a perfectly acceptable answer, and we're going to leave it just like that. All right, part B, we're going to find the area of R. So remember, area, whenever you do an area of something, we're going to find the top minus bottom. And I'm going to go ahead and draw a line here. There's our top minus bottom. So this is where identifying which graph is which is really helpful. So our area, remember we're going to take the integral. The integral is going to be the intersection points, or the limits are going to be the intersection points. So 0, as we can see on the graph, and 1/2. And top minus bottom, so in this case the top is our g of x. G of x minus f of x dx. Now, they're labeled as g of x and f of x, which is great, so we can just leave it like that. But the problem is, remember, this is a non-calculator question. Okay, we only had question 1 and 2 that involve calculators, so we actually have to work this out. So we got 0 to 1/2, g of x. G of x was sine of pi x minus f of x, 8x cubed. So in order to integrate this, we got something inside of sine of pi x. So over here on the side, I'm going to do some u substitution. U is going to be pi x. du is going to be pi dx. So I don't have a pi, so I'm going to bring that pi over as 1 over pi du equals dx. And so if I were to separate this, this is going to be 1 over pi sine of u. And remember, the antiderivative, or the integral of sine of u, is going to be negative cosine. So negative 1 over pi cosine of u. Let's put u back in there, that pi x. There's that one. And then minus, we can do this one using power rule real quick. All right, add 1, so that becomes x to the 4th, and then divide by 4. 8 over 4 gives us 2. And we're going to evaluate this from 1/2 to 0. All right, from there we're going to go ahead and substitute in. So 1 over pi cosine of pi times 1/2 is pi over 2. All right, minus 2 times 1/2 to the 4th minus parentheses negative 1 over pi cosine 0 times pi is 0, and then minus 2 times 0 to the 4th. All right, and we don't have to simplify anything except for the trig. Trig has to be simplified always. So negative 1 over pi cosine of pi over 2, that's going to be 0, minus 2 times 1/2 to the 4th. We're going to leave it because why waste the time trying to figure it out? We could distribute if we want, or we can just leave it as negative 1 over pi. Cosine of 0 is 1, so we can leave it like that. And we all know that's just going to be 0. So that is a perfectly great answer for the area, and we'll just leave it like that. All right, so next part is C. Now C is a great one because we don't actually have to evaluate it. We just have to set up everything for C. All right, it says write but do not evaluate an integral expression for the volume of the solid generated when r is rotated about the horizontal line y equals 1. So if we go back to our graph here, we're looking at this horizontal line here. And if we take it around that line, you can see there's all this space in the middle. So whenever there's space, we're going to use the washer method. All right, so for washer method, that's pi integral of a to b big R squared minus little r squared. And we're going to do dx since we're going around a horizontal line. So we've got to find a and b. Well, a and b is just our limits as we've already had. So a is 0, b is 1/2. All right, for this particular problem, you actually got a point just for making sure you had the constant and the limits. This is important. Now you do have to have an integrand. You can't just stop there and get a point. You need to have more than that. But now we can figure out what r squared and little r squared is. So big R. Remember, big R, we're going to start on the axis of revolution, go all the way down until you hit the bottom of the shaded region. And then we're going to do top minus bottom. In this case, 1 minus. Now this is a perfect place where we can just write f of x. We don't actually have to write out the full function of f of x. And I'm going to put that in there as 1 minus f of x squared minus little r. Little r, start on the axis of revolution, go down until you hit the first line. That's going to be our little r. There's our big R. And little r, top minus bottom, is 1 minus the function of g of x. And again, I'm going to leave it like that so I don't have to recopy down g of x. Squared, and don't forget that dx. We always want to make sure we have that dx there doing that. And that is a great answer for part C, and that will wrap up question number 3.